Hello, saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
This is SpaceTime, Series 23, Episode 28, for broadcast on the 27th of April, 2020. Coming up on SpaceTime, stars dancing around a monster black hole proves Einstein was right again. New data suggests that interstellar comet 21 Borisov originated from a red dwarf. And May 27 formally announced as the date Americans return to launching people into space off American soil. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have confirmed that stars orbit a supermassive black hole exactly as predicted by the great Professor Albert Einstein in his general theory of relativity. The new observations reported in the journal Astronomy and Astrophysics show that star S2 is orbiting around Sagittarius A star, the supermassive black hole at the centre of our Milky Way galaxy, in a rosette-shaped orbit rather than in an ellipse as predicted by Sir Isaac Newton's theory of gravity. Einstein's 105-year-old general relativity theory predicts that bound orbits of one object around another are not closed as Newtonian gravity predicts, but instead precesses forward in the plane of motion. This famous effect, first seen in the orbit of the planet Mercury around the Sun, was the first evidence in favour of general relativity theory as a description of gravity. Located some 27,000 light-years away, Sagittarius A star has some 4.3 million times the mass of the Sun, and it's orbited by a dense cluster of stars, providing a unique laboratory for testing physics under some of the most extreme environments in the universe. And one of these stars, S2, sweeps towards the supermassive black hole, getting as close as 20 billion kilometres, about 120 times the distance between the Sun and the Earth. That makes S2 one of the closest stars ever found in orbit around our galaxy's central black hole. At its closest approach to Sagittarius A star, S2's hurtling through space at almost 3% the speed of light, completing an orbit every 16 years. It's provided a team of scientists, including the study's lead author Reinhard Genzel from the Max Planck Institute, the opportunity to test general relativity using the European Southern Observatory's Very Large Telescope. But in order to do this, the authors needed to follow the orbit of S2 over a period of 27 years, finding for the first time that the star's orbiting the supermassive black hole just as predicted by Dr. Einstein. What it all means is that general relativity is providing a precise prediction for how much its orbit changes, and the latest measurements from this research exactly match that theory. Genzel says this effect, known as Schwarzschild precession, has never before been measured for a star around a supermassive black hole. The findings exquisitely measures S2's Schwarzschild precession in its path around Sagittarius A star. S2's orbit precesses, meaning that the location of its closest point to the supermassive black hole changes slightly with each orbit, in such a way that the next orbit is rotated with regard to the previous one, thereby ultimately creating a rosette shape. Most stars and planets have non-circular orbits, and therefore move closer and further away from the objects they're circling. The Earth's orbit around the Sun, and even the Moon's orbit around the Earth, are both examples of this. Genzel says that in the more than 100 years since Einstein first published his general theory of relativity, scientists have now detected the same effect in the motion of a star orbiting the compact radio source Sagittarius A star at the centre of the Milky Way. This observational breakthrough strengthens the evidence that Sagittarius A star must be a supermassive black hole over 4 million times the mass of the Sun.
My team and I are interested in studying massive black holes and the formation and evolution of the universe. If you envision the solar system and what Newton and Kepler knew about it, then you have the planets orbiting the Sun on elliptical or or circular orbits. And these ellipses, if there's nothing else in the way, is a figure which is always the same. Okay, it stays the same in the orbit, and the planet orbits around the sun for all times. Not so in general relativity. And there are several effects here. One is just due to the fact that the space-time makes the orbit of the planet precess, move forward, rotate, if you like, a little bit forward over time. And if the sun has an angular momentum, so it rotates, then there's a second effect, which is also a precession. We must, as scientists, that's the scientific method, keep on testing in different parts of parameter space whether a theory is correct in order to either, find it is correct or it is not correct. So that's what we're doing here. We're looking in part of a parameter space in mass, which has not been looked at. There's a second motivation we have, and that is to actually show that the object which is in the center of the Milky Way is a massive black hole. It plausibly is so far, but it might not. It might be a double object. It might be a triple object. Who knows? And so by making the measurements we are measuring or have been making, we are basically firming up the evidence ever more that this is indeed a supermassive black hole. Now, the third, if you like, is the biology of black holes and their environment, because black holes are not lonely objects. Because of their gravity, they are attracting other objects. One would expect, in fact, to be a massive black hole in the center of a galaxy to be tightly surrounded by a cluster of stars and maybe stellar black holes, or maybe so-called intermediate mass black holes. So these would be objects by a cluster of stars and maybe stellar black holes, or maybe so-called intermediate mass black holes. So these would be objects of, say, a few hundred to a few thousand solar masses. They have not been seen, but they might exist. The effect we're seeing now is basically true for objects with a mass. Now, general relativity, in contrast to Newton, also says that gravity affects the motion of massless things like light. So if you have a flashlight or a laser and you're close to a black hole and you shine that to us at a large distance, then the laser light has to climb out of the massive gravity around the black hole, and its energy lessens, and so we see it red shifted. So that's one of the effects. The next one we would like to see is the effect of the spin. So if a black hole is rotating, then it takes the space-time around with it, and a star which would be moving there, or gas which would be moving there, would see that and start to wobble. And if you can see that, you can measure the spin of the black hole.
That's Professor Reinhard Genzel from the Max Planck Institute. And this is SpaceTime. I'm Stuart Gary. Still to come, new observations suggest the interstellar comet 21 Borisov probably originated in a star system around a red dwarf. And May 27 officially nominated as the date for when Americans return to launching people into space off American soil. All that and much more still to come on SpaceTime. Okay, let's take a break from our show for a word from our sponsor, ExpressVPN, rated #1 by TechRadar. You may be wondering why you need a virtual private network. Well, it's in the name. It's all about privacy. Do you really want big brother tech companies, hackers, governments, and who knows who else snooping in on your online activities? Now, you might not have anything to hide, but it's still really creepy, and it could be dangerous for you and those you care about. Also, how often do you run across a website and you want to get information from it, but you find out that they're geo-blocked? It's all very frustrating, and it's becoming an increasing problem. And that's where ExpressVPN can help you. ExpressVPN's a simple and efficient way to protect your online privacy. It's internet without borders from the world's leading VPN provider. So, protect your online privacy today and find out how you can get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Visit tryexpressvpn.com/space to learn more. And of course, you'll find the link details in the show notes and on our website. That's tryexpressvpn.com/space. And now, it's back to our show.
You're listening to SpaceTime with Stuart Gary.
New observations suggest that interstellar comet 21 Borisov probably originated in a star system around a red dwarf. Borisov seemingly came out of nowhere late last year, swooping through our solar system from another part of the galaxy. Astronomers knew it was alien to our solar system because of its speed and course. But it still looked just like any other comet they had seen. Until now. Astronomers have used NASA's Hubble Space Telescope to study the comet's chemical composition, discovering that it's rich in carbon monoxide at levels simply uncharacteristic for comets from our solar system. One of the study's authors, Kathleen Mann from the Johns Hopkins Applied Physics Laboratory, says Comet 21 Borisov provides science with its first ever glimpse into the chemical building blocks of another solar system. Of course, comets are the solar system's icy dirt balls. The compressed mountains of ice, gas and dust dating back to the very formation of the solar system 4.6 billion years ago. As these dirty snowballs get closer to the sun, the warmth of the sun evaporates the ices, creating a bright coma or gas cloud. Scientists can then study the coma, examining its spectra to determine its chemical makeup, and letting scientists see how molecular compositions and abundances change with distance from the sun. Now, a comet from another star system would convey similar information, so the authors used the Hubble Space Telescope's cosmic origin spectrograph to analyze Borisov in ultraviolet light over 4 distinct periods between December 2019 and January 2020. This allowed them to watch as carbon monoxide, water, oxygen and carbon dioxide ices degassed into vapor from the comet. But the researchers were surprised to find that Borisov's bright coma was rich in carbon monoxide gas relative to water vapor, a finding that measurements from NASA's Swift Space Telescope was also able to confirm over the same period. In fact, the carbon monoxide was at least 50% more abundant than the water ice, and that's a value more than 3 times greater than the average for any comet measured in the inner solar system. Even though the composition of comets in our solar system can vary significantly from one comet to the next, astronomers have never seen a comet this close to the Sun with this much carbon monoxide compared to water. You see, carbon monoxide ice is an extremely volatile molecule, shifting from ice to gas with the slightest ray of sunshine. Now, in our solar system, that phase change begins around 18 billion kilometers from the Sun, almost 3 times the distance between Pluto and the Sun at its furthest point. On the other hand, water resists sublimating into a gas from a solid until the comet crosses what we call the snow line, near the inner edge of the main asteroid belt between Mars and Jupiter, around 322 million kilometers from the Sun. And for comets once inside the snow line, water almost always dominates over other gases. In fact, only a couple of comets have ever broken that rule. But even those, when compared with the amount of carbon monoxide Borisov puts out at any distance, were significantly lower. Borisov's wealth of carbon monoxide implies that it came from a planetary formation region that was very different in terms of its chemical properties compared to the disk from which our solar system was formed. The authors suggest that Borisov probably formed far from a star, at a point in the star system where carbon monoxide ice would be stable, but where perturbations from a large planet could still eject the comet from its home star system. Reporting in the journal Nature, the authors say that all these pieces tend to suggest that Borisov probably belonged to a disk of icy, dusty debris around a red dwarf star, the most abundant star type in the Milky Way galaxy. Red dwarfs are relatively small, cool stars, at best just half the mass of the Sun and just a tenth of its luminosity. And what that means is that carbon monoxide could remain in ice at just 1 billion kilometers from the star, and that's roughly 18 times closer than in our solar system, and many red dwarfs are likely to have large planets orbiting at those sort of distances. While it's impossible to determine the exact star Borisov came from, the molecules it's spewing out have provided enough clues for researchers to at least picture what that home system may have looked like. Borisov made its closest approach to the Sun around December 30th, 2019, and is now on its way out of the solar system. Scientists will continue studying this fascinating interstellar visitor as long as they can, until it ultimately leaves our solar system and returns to the space between the stars. This is SpaceTime. Still to come. NASA confirms Americans will resume flying into space off American soil on May the 27th. And tensions between Iran and the West are escalating as Tehran undertakes another missile test dressed as a space mission in violation of its United Nations anti-nuclear agreements. All that and much more still to come on SpaceTime. NASA has confirmed that Americans will resume flying into space from American soil on May 27. The United States has been relying on Russian Soyuz flights to get people into space ever since the earlier retirement of the space shuttle fleet with the landing of Atlantis on STS-135 way back on July the 21st, 2011. It'll be a major milestone for NASA's Commercial Crew program, designed to use private contractors to transport crew to and from the space station, allowing NASA instead to focus on its Artemis deep space missions to the Moon and Mars using its new Orion capsule and SLS rocket. And the first American crew to fly off American soil in a long time will be Robert Bencomb and Douglas Hurley, who'll fly to the International Space Station in a SpaceX Crew Dragon 2 capsule from Launch Complex 39A at the Kennedy Space Center in Florida. However, the Demo 2 flight won't be the 3-hour to-orbit fast rendezvous journeys which have become commonplace for Russian Soyuz missions to the space station. Instead, SpaceX are planning a more sedate 24-hour flight to the orbiting outpost. At this stage, it's still not known how long the crew will remain on station before returning to Earth. In March 2019, a Dragon 2 capsule successfully undertook the Demo 1 unmanned test flight to the space station, returning to Earth and splashing down in the North Atlantic Ocean 6 days later. The new Dragon 2 capsules are based on the original Dragon capsule design, which was only ever used for cargo transport, although it was always designed to eventually carry crew as part of NASA's Commercial Crew program. Like the original Dragon, the Dragon 2 is reusable and will launch on a Falcon 9 rocket. But unlike the original Dragon, which had to be grabbed by the space station's robotic arm and then maneuvered manually to a docking port, Dragon 2 will dock automatically. The new spacecraft are designed to remain docked to the space station for up to 210 days in orbit. The Dragon 2 looks different from its predecessor, with new updated outer mouldings, and they're also different inside, with new generation flight computers and avionics, new life support systems, and room for up to 7 crew members. Another big difference is instead of the iconic banks of controls, dials, switches and monitors which were so commonplace on spacecraft ever since the dawn of manned spaceflight, pilots will fly the Dragon 2 spacecraft using a touchscreen console. And while the original Dragon used 18 Draco reaction control system thrusters for main propulsive, attitude control, maneuvering and reaction systems, the Dragon 2 will use just 16 side-mounted Draco thrusters, together with 8 Super Draco rocket engines, 2 fitted in each of 4 side-mounted thruster pods. Each Super Draco will be some 200 times larger and more powerful than the conventional Draco RCS thrusters. They'll provide propulsion for the emergency escape system to fly the capsules out of harm's way during a launch or ascent emergency. They'll also be used for orbital maneuvers, and originally they were also designed to be used for propulsive landings, although that's been put on the back burner for now in favour of parachute splashdowns at sea. Dragon 2 also differs from its predecessor in using side-mounted solar arrays fitted directly onto the service module hull, instead of the original Dragon's deployable solar arrays, which were extended once in orbit. The service module, called the trunk by SpaceX, also houses all the auxiliary equipment and heat removal radiators, and it has little fins on it to provide aerodynamic stability during emergency aborts. The new spacecraft also uses a movable ballast shield, which provides more precise attitude control of the capsule during atmospheric entry. As well as the crew version of the Dragon 2, there'll be a cargo version capable of carrying up to 3,307 kilograms of supplies and equipment, which is being introduced now to replace the original Dragon cargo ship, which completed its final mission earlier this month. You're listening to SpaceTime. Still to come, tensions increase between Iran and the West as Tehran conducts another missile test disguised as a space launch. And later in the science report, a new study warns that people infected with COVID-19 may become contagious a day or two before they start to feel ill. All that and more still to come on SpaceTime. Tensions between the West and Iran are continuing to escalate, with Tehran undertaking another missile test in violation of its United Nations anti-nuclear agreements. Tehran claims the launch utilized a Gahast or messenger two-stage rocket to place a NOAA military spy satellite into a 425-kilometer high low Earth orbit. The launch apparently took place from the Islamic Revolutionary Guard's Shahrud missile range, 330 kilometers northeast of Tehran. Now, if accurate, it's a major development in Iran's Gahast family of air-to-surface guided missiles. You see, these are normally designed to be launched from fighter jets and carry 900-kilogram Mark 84 smart bombs over a range of only about 100 kilometers. It would also mark a major departure from Tehran's previous practice of using North Korean-based Scud ballistic missile technology for their space flights. Like that of its close ally and technological partner North Korea, experts see Iran's space program as a thinly disguised cover to develop missiles ultimately capable of delivering thermonuclear warheads. This successful launch follows a series of recent failures, including an attempt in February to launch a Simur rocket into orbit, another failed Simur launch just over a year earlier in January 2019, followed by the failure of a Safar rocket a month later, and then a spectacular launch pad explosion during fueling at the secret Imam Khomeini missile launch complex. Last month, the United Nations International Atomic Energy Agency criticized Tehran for not answering questions about possible undeclared nuclear material and nuclear-related activities at 3 locations. The nuclear watchdog warned that the Islamic Republic had almost tripled its stockpile of enriched uranium since November, from 372 kilograms up to 1,021 kilograms, in violation of its 2015 anti-nuclear accords. This means that with weapons-grade enrichment, Iran would only need another 30 kilograms of uranium to produce an atomic bomb. The oil-rich nation insists its nuclear program is exclusively for peaceful power generation purposes. But Iran has also refused to allow International Atomic Energy Agency inspectors access to 3 suspected nuclear sites where traces of enriched uranium residue has been found, including one site at Taqwazabad, which Tehran describes as a carpet-cleaning factory. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with a science report. New research warns that people infected with COVID-19 may be most contagious a day or two before they start to feel ill. The findings, reported in the journal Nature, suggest an estimated 44% of COVID-19 cases may spread from person to person before symptoms appear. The findings mean efforts to track down contacts of people with COVID-19 should include those encountered several days before a patient's symptoms begin. Scientists found swabbing the noses of 94 coronavirus patients found levels of the virus's genetic material peaked immediately after the onset of symptoms, then declined over the following 21 days. The authors say the findings suggest that virus production may be strongest at the start of infection, before the body's immune system kicks in to kill viruses and reduce symptoms. Researchers giving antibody-rich plasma to severely ill COVID-19 patients are reporting significant improvements in some cases. The pilot study findings, reported in the Proceedings of the National Academy of Sciences, include one trial in which 10 patients were given a so-called convalescent plasma, resulting in a rapid drop in the virus load in their bodies. Researchers say that within 3 days, doctors saw improvements in the patient's symptoms ranging from shortness of breath and chest pains to fever and coughs. However, doctors point out that larger randomized trials will be needed in order to confirm the findings. Meanwhile, a separate trial administering convalescent plasma to 5 patients, reported in the Journal of the American Medical Association, also found improvement in symptoms within 10 days of their infusion. The findings raise hopes that donated blood from people who have recovered from COVID-19 could be used to boost the immune systems of more vulnerable people and help fight the infection. A new study of more than 2,000 toddlers have found that those who watched television or videos at 12 months of age were more likely to show greater autism-like symptoms by the age of 2. A report in the Journal of the American Medical Association found that kids who had less interactive play with their caregiver at 12 months of age were also more likely to have greater autism spectrum symptoms. The researchers suggest that parents should avoid screen viewing for kids younger than 18 months. The concentration of atmospheric methane has reached new record levels. Data from a network of sampling stations operated by NOAA, the United States National Oceanographic and Atmospheric Administration, show that concentrations of the potent greenhouse gas are rising with an accelerating rate of increase. Methane can come from natural sources such as wetlands, but also from human activities including oil and gas extraction and from livestock farming. Climate scientists are describing it as one of the fastest growing rates in the last 20 years. Well, I've got to admit, I've not visited many entertainment sites since I stopped attending the ARIAs, but it would appear that at least some of them are covering more than the usual who was seen with who and why they were later arrested gossip. And it appears at least one of them has come up with a sensible list of 10 scientific explanations for paranormal activity, as Tim Mendham from Australian Skeptics explains.
I remember on a TV show from the UK where someone sort of asked the question, how do you know your house is haunted? And I think it was Jimmy Carr, the comedian, said, it's not. That was the way to know. Anyway, all these suggestions for what people might believe is ghosts, etc., or paranormal activity in their house. A particular article that appeared on, I don't know this site very well, it's an entertainment site called The Talko. And I don't know it, but people can look it up, Talko, The Talko. And these ghosts are real or not. First reason is infrasound, which is a very, very low sound, but often below the level of hearing.
If you're an elephant, you'd be familiar with it.
It's probably an elephant you'd be familiar with it. Yeah, so it can be emitted through volcanic activity, wind, the ocean, and even by elephants. Yes, there you are. So not a lot of volcanic activity around where I am. Electromagnetic fields, which are overrated anyway, as far as their impact on people.
I've been using them to make a living all my life. So
well, actually,
I quite like electromagnetic fields, especially the radio wave frequencies.
I've got a phone to my head at the moment, so I'm using those too. Okay, mold. And this is actually something which has been discussed quite a lot, actually, that toxic mold on your walls, etc., or the walls of... If you're going to a haunted house which hasn't been open for a long time and you get sort of wet environment and it's mouldy walls, you can actually get some sort of psychedelic sort of reaction from the mold itself. Carbon monoxide poisoning, yes, that's true. That can upset you. Gas leaks, that sort of thing, or whatever, can obviously send you off. Sleep paralysis, which is this phenomenon that you wake up, or you think you wake up, you might be in a dream and you cannot move.
This is when you're abducted by aliens, isn't it? And they're standing in the bedroom looking at you and things like this.
Yeah, so you're waking up sort of halfway through the wrong time of your sleep cycle, and you just feel like you can, and you believe you can't move, and you can't move, and therefore you've figured you're being held down by something, but actually not. One of the most interesting is exploding head syndrome.
Okay, now, I've not heard of this.
So I get this all the time. I've obviously got an exploding head. You know that thing that when you're falling asleep and suddenly you jump?
Yes. Oh, yes.
Just as you're drifting off to sleep, right? You get that annoying jump like something's happened and you sort of say, oh, bugger, falling fairly. This is actually a bang you hear, exploding head. It's actually a bang like, I've had this happen quite a lot. Yeah, and it's annoying because you think, oh, something happened in the house. Has all the crockery fallen off or something? What's happened? But it's actually
the cat jumped on the dishes.
Yeah, it's which is annoying because I don't have a cat. It's like the jumping when you're just falling asleep, and this is the same thing, that bang. Perfectly normal, nothing particularly ghosty or paranormal about it. Some people also say flashes of bright lights, at the same time. Just falling asleep and suddenly, whammo, you get hit with a torch in your face, but it's not there. It's just you having these dreams. Chronic sleep deprivation, sort of, if you really need sleep and you're not getting it, you probably can believe anything, and things happen to you, or you think you see things. Your senses aren't in the best form, so that's pretty straightforward. One of these things they reckon, let's say, might be the case is drug.
Well, that's the one that doesn't surprise me.
Doesn't surprise you at all. Now you get into the sort of areas, there's the influence of other people who say this house is haunted, and that you start believing that it's a haunted house. Mm-hmm. You go into a spooky house, you turn the lights off, you're sitting there with the ghost hunters who have their infrared goggles on and all this sort of stuff, and it feels spooky and it's a bit of fun, etc. It's like seeing a spooky film.
You can psych yourself into it really easily.
Well, that's why people go to see movies, scary movies, right? Yeah, I mean, and it works and it's fun, and therefore, but it doesn't necessarily mean that what you think you see is actually there. And that brings up to the last one, the power of belief. And people who believe in ghosts will tend to see ghosts, and those who don't will tend not to. I've always found it interesting that ghost hunters will hardly ever go into a house and say nothing there. They'll always find something of interest.
It's probably bad for business.
Bad for business, bad for their own fun. I mean, most ghost hunters aren't making money out of it. They're just going, the people who think they should be hunting down ghosts and being like Bill Murray, etc. But they wear their camouflage outfits and never quite figure out why. But
well, that way the ghosts can't see them, I guess.
Yeah, I guess. They got their backpacks on and all that sort of stuff.
Yeah.
I think they're sort of sincere people by and large, and they just really want to see ghosts. And if you really want to see something, you will.
That's Tim Mindham from Australian Skeptics. And that's the show for now. SpaceTime is broadcast on Science Zone Radio by the National Science Foundation in Washington, D.C., and through both iHeartRadio and on TuneIn Radio. Or you can subscribe and download SpaceTime as a free podcast through Apple, Stitcher, Bytes.com, Pocket Casts, SoundCloud, Spotify, YouTube, Audio Boom, Podbeam, Android, Castbox, from spacetimewithstuartgary.com, or from your favorite download podcast provider. You can help support the show and the work we do by visiting the SpaceTime online shop and grabbing yourself a few goodies, or by becoming a SpaceTime patron, which gives you access to commercial-free double-episode versions of the show, as well as bonus audio content and other rewards. Just go to our Patreon page through spacetimewithstuartgary.com for all the details. If you want more SpaceTime, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, at SpaceTime with Stuart Gary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to www.facebook.com/SpaceTime with Stuart Gary. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.
Hello, Saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.